Welcome to Geographic Information System. Okay. First and foremost, allow me to share my screen. Thank you. Okay. So GIS. So a geographic information system is a computer-based system designed to capture, store, manipulate, analyze, manage, and present all types of spatial or geographic data. So GIS is a set of tools that allow the processing of spatial information. So this set of tools is open-ended, but will include data, will include input data, storage, data manipulation, and reporting system. GIS is used for geographic information science, or we call it geospatial information studies, to refer to the academic discipline or career of working with a geographic or maybe with a geographic information system. And it is a large domain within a broader academic of geoinformatics. Okay, so let us visualize a question, analyze, interpret data to understand the patterns and trends. So GIS benefits organizations of all sizes, and in almost every industry, there is a growing interest in awareness of economic and strategic value of GIS. In general sense, the term describes any information system that integrates, stores, edits, analyzes, shares, and displays geographic information. Okay, so information systems allow transformation of data into information via structuring, formatting, conversion, and modeling. GIS transform data with a spatial component. A spatial component here refers to a location-based data with coordinates, okay, which is ENH or latitude and longitude, and on below or above its surface. The data with where. So GIS technology has been called by different names like geospatial information systems, computer-aided mapping, automated cartography, land information systems, environmental information systems, and etc. Now, how do you define GIS? So we have a number of definitions which I'm going to give you. Okay, so another definition from READ is it is a system of hardware, software, and procedure designed to support the capture, management, manipulation, analysis, modeling, and display of spatially referenced data for solving complex planning. Okay, then USGS also comes in and says it's a computer system capable of assembling, storing, manipulating, displaying geographically referenced information. So in all the aspects, we have the issue of the capture, the storing, manipulating. Okay, so we can go on to look at these other definitions, okay, of which you can actually check them out maybe at your free time. Okay, so in short, we have a number of definitions that talk about GIS. So in general, when we talk of GIS, we're talking about a computer-based system that supports the capture, management, manipulation, modeling, and display of spatial reference data, and provides planning, management, development, and humanitarian solutions. Okay. We'll look at the brief history of GIS. The first known use of GIS was by Roger Tomlinson in 1968 in his paper, a geographic information system for regional planning. Okay, and he's also known as the father of GIS. Okay, 1958. 1958. We have the John Snow's 1855 map of Soho cholera outbreak showing the cluster of cholera cases in London. That was 1854, and it goes on. Then 1854, John Snow depicted a cholera outbreak in London using points to present the locations of some individual cases, and early successful use of geographical methodology in epidemiology, while the basic elements of topographic theme existed previously in cartography. Okay, so John Snow was able to do that. So we can go on. I will be able to give the few summary of that. Okay, I'll go to the components of GIS. Okay, GIS has a number of components. Okay, an operational GIS has serious components that you can command to come up with the system. And the following are the components. So we have hardware. Okay, hardware is a simple term which is used to refer to the things that we can see in Dutch. Here you're saying hardware is a computer system on which GIS operates. So today, GIS software runs on a wide range of hardware types, from centralized computer servers to desktop computers used in standalone and network configurations. Software. So software provides the function and tools needed to store, analyze, display information. So a review of the key GIS software systems. Okay, we'll look at a review of such systems. Okay, and then data. The most important component of GIS is data. Okay, here in Zambia, we say data number one because without any data, you cannot do anything. Okay, so geographic data and related tabular data can be collected in in-house, compiled to custom specifications, or occasionally purchased from commercial data. A GIS can integrate spatial data with existing data resources, often stored in corporate DBMS. The integration of spatial data, often proprietary is software owned, okay? And tabular data stored in DBMS is a key function of GIS. Then the other component of GIS that we have, people, meaning you and me. Okay, so GIS technology is of limited value without people who manage the system. It is you that work on those systems. So we are an important component to GIS and develop plans for applying it to real world problems. So GIS users range from technical specialists who design the system to those who use it and help them perform that daily work. So the identification of GIS specialists versus users is often critical to the proper implementation of GIS technology. The other component is methods. So a successful GIS operates according to a well-designed implementation plan and business values, which are the modules and the operating practices which are actually unique to the organization. Then GIS has subsystems and functions. So a GIS has four main functional subsystems, which are data input system, data storage system, and also a retrieval system, data manipulation, and analysis system, and a data output and display subsystem. Okay, what is data input? A data input subsystem allows the user to capture, collect, and transform spatial data into a digital form. The data inputs are usually derived from combination of hard copy, math, aerial photograph, remotely sensed images, surveys, and etc. So Here's a sample image of GIS functions. So the capture, you can see, okay, here, then when data is actually captured, it will be stored and also on. Okay, data storage and retrieval. The data storage and retrieval subsystem organizes the data, spatial and attributes in a form which permits it to quickly be retrieved by the users for analysis and permit rapid, accurate updates to be made to the database. So this component usually involves the use of DBMS for maintaining attributes data. Data manipulation and analysis. So the data manipulation and analysis subsystem allows the user to define and execute the spatial attributes to go and to generate derived information. This subsystem is commonly thought of as the heart of GIS. It okay, it is the heart, and it does everything. Data output. The data output subsystem allows the user to generate geographic information displays, anomaly maps, and tabular reports representing derived information products. Okay, so for now, okay, basic GIS functions are contained in a definition, which includes the capture, the query, and so on. All right, allow me to end here, and we will continue with GIS data models, okay, or maybe organization. This has been Preston Winger, and we shall continue later on. Bye-bye for now.